kinetic molecular theory?
Kinetic
Kinetic molecular theory is a scientific theory that describes the states of matter and how they transform into one another. It is a model used to explain the behaviors of matter. The more kinetic energy a molecule has, the faster it's going to move. When heat is added to a substance, the molecules and atoms vibrate faster. As atoms vibrate faster, the space between atoms increases.
Why is it important?
It's important in chemistry because the kinetic molecular theory provides an understanding of things like temperature and pressure. This theory allows chemists to understand what it means for something to be hot or cold, how heat is transferred from one material to another, and why the temperature, pressure, and volume of a gas are all related. The amazing thing about kinetic molecular theory is it can be used to derive the ideal gas law. To understand the kinetic molecular theory, we need to know the phase changes of solid, liquid, gas, and kinetic energy. What is kinetic?
Kinetic energy is when an object is in motion, like Jayla.
Kinetic energy is energy of motion, basically the movement of an object, particle, or a set of particles. What are the three phases of matter?
You don't matter.
Yeah. But I know it's solid, liquid,
Yeah.
and gas. Yeah. And plasma too.
Solid has a fixed shape and has a definite volume. Liquid has no shape and it does have a volume, and it's compressible. Gas has no shape and is easily compressible and has no volume. The theory of matter states that atoms and molecules are in constant motion and that the higher the temperature around them, the higher their speed will be. In other words, the increased heat energy will make atoms and molecules move faster. This ties into the states or phases of matter. In the solid phase, atoms and molecules are closely together and vibrate in random directions. In liquid phase, they move around and collide with each other. Then in the gas phase, they move around much faster and spread out or expand. Energy is necessary for a phase change, often in the form of heat energy. All particles have energy, and the energy varies depending on the temperature the sample of matter is in, which determines if the substance is a solid, liquid, or gas. Solid particles have the least amount of energy, and gas particles have the greatest amount of energy. The temperature of a substance is a measure of the average kinetic energy of the particles. A change in phase may occur when the energy of particles is changed. There are spaces between particles of matter. The average amount of empty space between molecules get progressively larger as the sample of matter moves from solid to liquid to gas. This is solid at its molecular level. Solid has a defined shape, it does not flow, and is virtually impossible to compress, and it expands if heated, but usually less than liquid or gas. Particles in solid, they're strongly bonded to each other, vibrate a little but not much compared to liquid and gases. They vibrate faster when heat is added. This is liquid at its molecular level. Liquid has no defined shape. It can float to take the shape of the bottom of a container and is difficult to compress. Particles in liquids, they're weakly bonded, so their bonds break easily. They vibrate and move more than those in solid. They move faster when heat is added. This is gas at a molecular level. Gas has no fixed shape. It spreads easily to fill a container and is easily compressed. Gas particles. They're free and have no bonds between them. They have much more energy than those of solid or liquid. They fly around, bouncing off each other and the walls of the container. Postulates in kinetic molecular theory, which include: number 1, gases are composed of large number of particles that behave like hard, spherical objects in a state of constant random motion. Number 2, these particles move in a straight line until they collide with another particle or the walls of the container. Number 3, the particles are much smaller than the distance between particles. Most of the volume of gas is therefore empty space. Number 4, there is no force of attraction between gas particles or between the particles and the walls of the container. Number 5. Collisions between gas particles or collisions with the wall of the container are perfectly elastic. None of the energy of a gas particle is lost when it collides with another particle or with the wall of the container. Number 6. The average kinetic energy of a collection of gas particles depends on the temperature of the gas and nothing else.
Number 1. According to the kinetic molecular theory, particles of matter A. are in constant motion, B. have different shapes, C. have different colors, or D. are always fluid. The correct answer for number 1 is A. According to the kinetic molecular theory, particles of matter are in constant motion.
Number 2. The kinetic molecular theory explains the behavior of A. gases only, B. solids and liquids, C. liquids and gases, or D. solids, liquids, and gases. The answer is D. The kinetic molecular theory explains the behavior of solid, liquid, and gases.
Number 3. According to the kinetic molecular theory, which substances are made of particles? A. Ideal gases only, B. all gases, C. all matter, D. all matter except solids. Correct answer for number 3 is C. According to the kinetic molecular theory, all matter are composed of particles.
Number 4. According to the kinetic molecular theory, particles of a gas A. attract each other and collide, B. repel each other and do not collide, C. neither attract or repel but still collide, or D. neither attract or repel and do not collide. The answer is C. According to the kinetic molecular theory, particles of a gas neither attract or repel but still collide.
Why does higher temperature result in a faster reaction? A. It increases the surface area for a reaction. B. It increases the number of effective molecular collision. C. It increases the pressure of the reactant. Or D. It lowers the activation energy for its reactants. The correct answer is A, because temperature affects the rate of the reaction, because as temperature increases, so does kinetic energy. This means that molecules are moving rapidly, resulting in more collision, thus it increases the rate of production formation.
The kinetic molecular theory of matter is a concept that basically states that atoms and molecules possesses an energy of motion, kinetic energy, and we perceive as temperature. In other words, atoms and molecules are constantly in motion, and we measure the energy of these movements as the temperature of the substance increases.
This means if there's an increase in temperature, the atoms and molecules will gain more energy or kinetic energy and move even faster. It is important because it shows the characteristics of solid, liquids, and gases.
A pass on the final exam. Go real fast. Yeah.
Like a gas. Yeah. Because we're molecules.
With
And Alita is really cool. Yeah.
like a jungle gym.
Ha, ha.
My name's Tim.
Yeah, yeah.
I'm in the gym.
Ha.
Fairly off here.
Yeah.
Is that Darren? Solid, gas, liquid. What is that called?
A phase change.
Yeah!
Wait, plasma's actually like
No.
like
It's
No.
a phase.
no, okay, but is it like a
Matter?
It matters because it is plasma.
Matter
Shut
matters.
up. What is plasma?
A phase.
I'm interviewing you now. Oh.
Hey, don't know how to say it, but I know what it is. It has
Huh.
something to do with solid, liquid, gas,
Yeah.
and
Plasma.
plasma. Station,
Huh.
station,
Solid.
station. Solid. You stick to each other. You vibrate. Yeah, yeah. Liquid.
Huh.
You just do this. Yeah, you just move. Gas. You go real fast.
Gas.
Plasma.
And plasma.
Plasma. You
going even
moved out of
faster.
space. You fly. You like
gone.
the Flash, Superman. It's plasma. That's
In
why
the
he's
past.
allergic to kryptonite.
Cause you know he ain't got might. What?
What are the three phases of matter?
What did you measure?
What is kinetic?
Kinetic energy is when an object is in motion. Like Jayla.
You're kinetic right now.
I'm in motion.
Kinetic motion.
Boys in motion.
Huh.
But I'm not a guy, so girls in motion.